Let's say I wanted to evaluate functions, but was given something like this. These are called piecewise functions. Basically, they're pieces of different functions to create one function. So piecewise. And this right here tells us where we want to define each of our functions. So we're going to graph or use 3x if we have an x value less than 0, or use negative 2x plus 1 if we have an x value greater than or equal to 0. So for example, if I'm evaluating the point f of negative 3, I'm wondering, well, where do I input that? Well, negative 3 is less than 0, therefore I input it into the 3x equation and get a value of negative 9. If I want to know what f of 2 is, well, 2 is bigger than 0, therefore I use this equation. Negative 2 times 2 plus 1 gives me negative 4 plus 1, or negative 3. Likewise, if I want to know f of 0, well, x is equal to 0 for this bottom one. So I get negative 2 times 0 plus 1, or 0 plus 1 for a value of 1. Looking at a piecewise function that has 3 instead of 2 and is even a little more complicated, we have that these three functions evaluate over these three intervals. So, say for example, I want to know what f of negative 10 is. If you just asked yourself, well, is negative 10 less than negative 5, and said yes, you were correct. So you're using the top function. Negative 10 squared, remember, is negative 10 times negative 10, which equals a positive 100. If we want to know f of 0, well, 0 falls in between negative 5 and 5, therefore we use the second equation. Negative 2 times 0 is 0. Lastly, f of 5, well, 5 falls on this line as well because we're equal to, so negative 2 times 5 is negative 10. One more example, f of 11. 11 greater than 5, yes, therefore use this bottom function. Well, notice there's no x to plug in, right? Well, that just means no matter what value you pick on this function, as long as it's greater than 5, you're using this one, and that means it's 3 everywhere, no matter what x, because there's no x to put in or have it depend on.